Welcome to Projectventive channel. In our today's video we are going to talk about TERRRA, Boston Dynamic quadruped robot. Please subscribe this channel. Big Dog is a dynamically stable quadruped military robot that was created in 2005 by Boston Dynamics with Foster Miller, the NASA Jet Propulsion Laboratory, and the Harvard University Concord Field Station. The Boston Dynamics Python API has a corresponding set of clients for each service, which are created off of the robot object. Boston Dynamics' top competitors include Vision Nav Robotics, Mushiny Intelligence, and Symbio. Police departments use Spot to inspect suspicious packages and environments for hazardous materials or explosives, assess hostile threats remotely, and to search structurally dangerous environments in emergency response scenarios. We believe that our robots can be used to keep first responders and the public safe. A new contract notice from the UK's Atomic Energy Authority, UKAEA, for the premium Spot Enterprise TERRRA Robot Dog, Spot Arm and all ancillary equipment, puts the number at £181,492, $204,840, excluding VAT. Big Dog is a dynamically stable quadruped military robot that was created in 2005 by Boston Dynamics with Foster Miller, the NASA Jet Propulsion Laboratory, and the Harvard University Concord Field Station. It was funded by TERRRA, but the project was shelved after the Big Dog was deemed too loud for combat. History. Big Dog was funded by the Defense Advanced Research Projects Agency, TERRRA, in the hopes that it would be able to serve as a robotic pack mule to accompany soldiers in terrain too rough for conventional vehicles. Instead of wheels or treads, Big Dog uses 4 legs for movement, allowing it to move across surfaces that would defeat wheels. The legs contain a variety of sensors, including joint position and ground contact. Big Dog is 3 feet, 0.91 meters, long, stands 2.5 feet, 0.76 meters, tall, and weighs 240 pounds, 110 kilograms, making it about the size of a small mule. It is capable of traversing difficult terrain, running at 4 miles per hour, 6.4 kilometers per hour, carrying 340 pounds, 150 kilograms, and climbing a 35-degree incline. Locomotion is controlled by an onboard computer that receives input from the robot's various sensors. Navigation and balance are also managed by the control system. It can stand up, sit down, walk with a crawling gait that lifts one leg at a time, walk with a trotting gait lifting diagonal legs, or trot with a running gait. The travel speed of Big Dog varies from a 0.45 miles per hour, 0.2 meters per second, crawl to a 3.6 miles per hour, 1.6 meters per second, trot. The Big Dog project was headed by Dr. Martin Berler, who received the Joseph Engelberger Award from the Robotics Industries Association in 2012 for the work. 5. Dr. Berler, while previously a professor at McGill University, headed the robotics lab there, developing 4-legged walking and running robots. Built onto the actuators are sensors for joint position and force, and movement is ultimately controlled through an onboard computer which manages the sensors. Approximately 50 sensors are located on Big Dog. These measure the attitude and acceleration of the body, motion, and force of joint actuators as well as engine speed, temperature and hydraulic pressure inside the robot's internal engine. Low-level control, such as position and force of the joints, and high-level control such as velocity and altitude during locomotion, are both controlled through the onboard computer. Big Dog was featured in episodes of Web Junk 20 and Hungry Beast, and in articles in New Scientist, Popular Science, Popular Mechanics, and The Wall Street Journal. On March 23, 2008, Boston Dynamics released video footage of a new generation of Big Dog known as Alpha Dog. The footage shows Big Dog's ability to walk on icy terrain and recover its balance when kicked from the side. The refined equivalent has been designed by Boston Dynamics to exceed the Big Dog in terms of capabilities and used to dismounted soldiers. In February 2012, with further TERRRA support, the Militarized Legged Squad Support System, LS3, variant of Big Dog demonstrated its capabilities during a hike over tough terrain starting in the summer of 2012. TERRRA planned to complete the overall development of the TERRRA system and refine its key capabilities in 18 months, ensuring its worth to dismounted warfighters before it is rolled out to squads operating in theater. TERRRA must be able to demonstrate its ability to complete a 20-mile, 32 kilometers, trek in 24 hours, without refueling, while carrying a 400-pound, 180 kilograms, load. Please subscribe this channel. A refinement of its vision sensors will also be conducted. At the end of February 2013, Boston Dynamics released video footage of a modified big dog with an arm. It is believed that it can lift weights around 50 pounds, 23 kilograms. Discontinuation. At the end of December 2015, the Big Dog project was discontinued. Despite hopes that it would one day work like a pack mule for U.S. soldiers in the field, the gas-powered engine was deemed too noisy for use in combat. A similar project for an all-electric robot named Spot was much quieter, but could only carry 40 pounds, 18 kilograms. Hardware: it is powered by a 2-stroke, 1-cylinder, 15 brake horsepower, 11 kilowatts, go-kart engine operating at over 9,000 RPM. Each leg has 4 actuators, 2 for the hip joint, and 1 each for the knee and ankle joints, for a total of 16. Each actuator unit consists of a hydraulic cylinder, servo valve, position sensor, and force sensor. Onboard computing power is a ruggedized PC, 104 board stack with a Pentium 4 class computer running QNX. Construction capabilities: add sensor payloads and software to Spot to customize its capabilities to meet your needs. Site progress monitoring: autonomously capture 360 degrees images and video indoors or on challenging exterior sites. Frequently captured site progress snapshots can be contextualized in construction documents and used to automate insights and work-in-place reporting through emerging AI technologies. Comprehensive site visibility: Spot brings automation to the field for efficient data collection. Accurately and frequently capture the reality of your job site and act on valuable data insights. BIM model compare. Equip Spot with a laser scanner and program routine scanning routes to collect highly precise 3D data on construction progress. Remotely measure critical areas of the site and compare as-built conditions to design intent within BIM to detect clashes early and minimize rework. Digital twin creation: efficiently create accurate as-built models with 4D asset data that can be used for building operations. Worker health and safety: use Spot to survey confined spaces and keep workers out of hazardous environments. Feed image data on programmed routes into specialized downstream software for the detection of health and safety issues. Spot is Boston Dynamics' nimble new quadruped robot. Boston Dynamics introduces a new quadruped that's quieter and more agile than LS3. Boston Dynamics is infuriatingly cool. They have to be the only robotics company out there that can just post a YouTube video of an incredibly agile autonomous quadruped named Spot, with a 4-sentence description, and that's it. No info on their site, no press release, no interviews. It is electrically powered and hydraulically actuated. Spot has a sensor head that helps it navigate and negotiate rough terrain. We've pinged our contacts at Boston Dynamics for more details, but until we hear back from them, and now that they belong to Google, we'll probably hear from them, like, never. Update the 2nd of November 15. Boston Dynamics got back to us, so, yeah, that was sooner than never. Let's see what we can figure out from the video. We'd be surprised if this didn't have a significant impact on the range, endurance, and/or performance, especially payload capacity, of Spot relative to some of their other robots. However, they managed to make the most recent update of Atlas run on batteries that also power a pump, so maybe Spot is leveraging the same technology. Update: Boston Dynamics confirmed that Spot's power system shares some elements from the new Atlas power system. Spot doesn't necessarily look like it's built specifically for speed or payload capacity, suggesting that it's not the next generation of either LS3 or Wildcat. We've heard that the legs on these robots can be placed with their knees facing either backwards or forwards, but it's, maybe, worth pointing out that Wildcat has forward-facing knees, Cheetah does too, and LS3 has a mix. If I had to guess based on nothing at all, I might speculate that the LS3 leg configuration is for payload, and the Wildcat leg configuration is for speed. So maybe Spot's legs are designed for agility. Or maybe it doesn't matter at all. Like, it doesn't care that there are stairs there, it just sees a steep and bumpy slope, and then goes upstairs like it would any other terrain. Also tucked away where Spot's head would be, if it had a head, looks like the same sort of vision senses that Atlas has, but it's a bit hard to see. The Velodyne isn't mounted in a way that it can see what's immediately in front of the robot, so for autonomous operation, it'll need to rely on something else for close-in sensing. The robot's adaptability is a huge asset here. Though, since it's so dynamically stable, it doesn't need to calculate exact foot placement in advance, it can just go. The big question that we have now, besides all of the other big questions about how this machine works and what it can do, is why does this robot exist? As in, what was it built for? Back when Boston Dynamics was primarily working for the military, it was easier to discuss potential applications, but now that the company is part of Google, maybe the reason is just because we can, and it's cool. Or maybe this is an urban delivery robot. In any case, we're very glad to see that Boston Dynamics is still making awesome robots and hasn't completely disappeared into the Google void. A Boston Dynamics spokesperson told the Robot Report via email. Innovation is the lifeblood of Boston Dynamics, and our roboticists have successfully filed approximately 500 patents and patent applications worldwide. We welcome competition in the emerging mobile robotics market, but we expect all companies to respect intellectual property rights, and we will take action when those rights are violated. The Robot Report reached out to Ghost Robotics but had not heard back at press time. This article will be updated if new information is learned. News of the lawsuit was first reported by Law 360. Boston Dynamics is seeking infringement damages and pre- and post-judgment interest. It claims Ghost Robotics is infringing on the following U.S. patents: 9,308,648, systems and methods for robotic self-right; 9,662,791, systems and methods for robotic self-right; 1,123,869, robotically negotiating stairs; 9,387,588, handling gate disturbances with asynchronous timing; 11,073,842. Perception and fitting for a stair tracker, 10,253,855, screw actuator for a legged robot, 11,131,368, screw actuator for a legged robot. In the complaint, Boston Dynamics included photos of Ghost Robotics quadrupeds being tested by the U.S. Air Force in 2020 and 2021 at Nellis Base in Nevada. Thanks for watching. Please subscribe this channel.